We've talked about proportions in this class before, but starting in this section and in the coming chapters, we're going to be dealing with proportions a lot. So I want to review what proportions are and what they mean. So let's start with the definition. A population proportion is the fraction or ratio or percent of a population that possesses some characteristic. So for example, in 2006, the proportion of adult Americans that were married was 55.7%. So here we're displaying this proportion as a percent, but there are other ways we could display it, right? We could display it as a fraction or a ratio. So I could write this, instead of 55.7, I could write this as 0.557, okay, in decimal form. Or if I want to write it as a fraction, I could write it as 55.7 over 100. Right? For example. So the fraction just tells you what percent of a population, or the proportion just tells you what percent of a population, what fraction of a population possesses some characteristic that we're interested in. Okay? Now, there's a few properties about proportions that would be useful to note. Properties of proportions. First, when we're measuring a proportion, there's only two possibilities. Either a member of a population possesses the characteristic we're looking for, or they do not. There are only two options. Either a member of the population possesses a characteristic, or they do not. Okay? Because of this, we can easily also find out what proportion of the population does not possess a characteristic. So in our example above, where we're looking at the proportion of adult Americans that were married, and we know that's 55.7%, that means the proportion of Americans that were not married is, well, if we look at all Americans, that's 100%. That includes all of them. And if we take out the proportion of Americans that are married, if we subtract that away, we're left with the proportion of Americans that were not married. So in this case, that's 44.3%. Okay? Another observation, proportions always lie between 0 and 1. proportions always fall between 0, which equals 0%, and 1, which is equal to 100%. Okay, and that makes sense, right? You can't have less than 0% of a population possess a characteristic, right? The least you could have is no member of the population possessing a characteristic. And the most you can have is everyone in the population possesses that characteristic. 100% of the population possesses the characteristic. So the proportion, the fraction of members of a population that possesses this particular characteristic, whatever characteristic we're looking for, has to be between 0 and 1, or 0% and 100%. Okay? Now, you may be looking at this and thinking, this sounds kind of familiar. This sounds a lot like probability. And really it is. The proportion of a population is also the probability that a randomly chosen member of the population possesses the characteristic. Whatever it is, whatever the characteristic is that we're measuring with the proportion. It possesses the measured characteristic. Okay, so in our example above, where we knew that 55.7% of adult Americans were married in 2006, that also tells us that if we randomly select an adult American in 2006, there's a 55.7% chance that the adult we select is married. Okay? So how do we actually calculate proportion? So for a population, the symbol we use to represent proportion is a lowercase p. Lowercase p is proportion. And for a population, we calculate proportion by counting the members of the population that possess the characteristic divided by the total number of members in the population. So here, p is the population proportion. X, capital X here, is the number of members of the population that possess the characteristic we're looking for. And N is just your population size. It's all the members of your population. How many are there? Okay, so we're even calculating this very similar to how we're calculating probability, right? We're just counting how many members of the population possess the characteristic we're interested in, divided by the total. Okay, that sounds a lot like probability. The difference between proportion and probability isn't really how we calculate it or even the number. It's the same number. It's how we think about it. Probability really is the idea of if we do this thing in the future, what's the chance that it will happen? Where proportion is just a measure of what does this population look like right now? What fraction possesses this characteristic? Okay, it's actually the same number, but we're thinking about it a little differently. Okay, so let's do a little quick example here just so we can understand this calculation. Suppose Menifee High School has 4,582 students, where 1,231 students of those students are freshmen. What proportion of MHS students are freshmen? So we know the formula. We want to calculate a population proportion. We want to calculate what proportion of the population of all students at this high school are freshman students. Okay, so we're just going to find how many members of the population have the characteristic we're looking for. In this case, the characteristic we're looking for is that they're freshmen, and we divide by the total number of students in the population. Okay, so the number of students that are freshmen, that's 1,231. That's the number of students that have the characteristic we're looking for. We're going to divide that by the total number of students in our population, our total population size, which is 4,582. Okay, and if I throw that into my calculator, that was 1231 divided by 4582. And so as a decimal, we get 0.26866. 0.26866. That's about 27%. So about 27% of the population of Menifee High School students are freshmen.